All right, good afternoon. My name is EddieLathamJones, and I am presenting today on insights into pedestrian fatalities, the geospatial analysis of racial disparities in pedestrian fatalities in Tucson, Arizona. So to get us started, the first thing I want to do is do the land acknowledgement statement that we respectfully acknowledge that the University of Arizona is on the land and territories of Indigenous peoples. I think that this is especially important in the context of this research that's taking place in Tucson, Arizona, and as you'll see from the research, that Native Americans are at an extremely heightened risk of being victims of pedestrian fatalities in Arizona. So begin for an introduction, a couple of different things. Of the 5 years of this study, which is 2017 to 2021, Tucson, Arizona saw an increase in pedestrian fatalities of 57%. Which is staggering. If you're looking at the years post that, the data is not available for in the data sets we were using. The Tucson Police Department reported that in 2022, that there were somewhere, I think it was 49 pedestrian fatalities is what we had last year. So the problem's not getting any better after this study area. Smart Growth America and the National Complete Streets Coalition named Tucson the 13th most dangerous city for pedestrians in 2022. And nationwide, over the past 20 years, we've seen an increase in pedestrian deaths of 37%. So this is a problem that's occurring across the nation, not just in Tucson or Arizona. In terms of who the victims are, there are a couple of different things to look at. There was a study in the 1990s that showed that American Indian fatality rates in Arizona were 6 to 13 times higher than the general population. Now that's an incredibly large range that you're looking at, like 6 to 13 times higher. So it's attempting what a lot of these studies that are doing per capita analysis and determining risk for population groups are trying to determine trip populations, time of day. They end up with these very large tables that are complicated to try to calculate what that risk is, which is why you see that variance. But certainly, obviously, if it's 6 to 13 times higher, it's a significant rate. There's a national per capita analysis shows that Black and American Indian populations are significantly overrepresented in terms of pedestrian fatalities, and that you can't get a very clean percent breakdown from those studies. They're looking at times of day and splitting all sorts of different factors, but are showing that generally significantly disparities there. Now, in terms of what Tucson and the place Tucson holds in terms of Arizona and the United States, in the bottom left-hand corner, you can see the 2020 census results that show that Tucson is about has twice the Hispanic and Latino population as the rest of the United States, is about 9% more non-white than the United States as a whole, and Arizona, you can see, falls in the middle. Now, this brings us to our question of why is there a disparity in the racial distribution of pedestrian fatalities, and to what extent does the racial and ethnic composition of census blocks in Tucson, Arizona contribute to the observed geographic pattern of pedestrian fatalities? And it brings us to our data. So the data sets we're looking at are covering the years 2017 to 2021. And the main data set we're looking at is the Fatality Analysis Reporting System. This was created by the National Highway Transportation Safety Administration starting in 1979, and provides comprehensive data on fatal traffic accidents. Everything like time of day, things like vehicle types, road types, information on toxicology for drivers, pedestrian victims, things like that. So it's incredibly comprehensive, but does have some limitations. The first limitation really in the context of the study is that it did not start tracking race until 1999. And even to this day, it's the information that's available on race and ethnicity will vary year to year and state to state. So there's some gaps that we'll see when we start to look at our data that came up in the study in particular. And then for demographic data of the census blocks, we looked at the American Community Survey, which has been around for about 20 years. It's produced by the US Census Bureau and published every year, and gives you a much more current and granular look in terms of what's happening in the census blocks than the every 10-year decennial census. In terms of our methods, we're going to look at a couple different things. First is just going to be a simple one-to-one population comparison. Who are the victims of these pedestrian fatalities and how do they compare to the population as a whole for the study area? Next, we're going to look at the distribution of the geographic distribution of fatalities. How significant is that? Are they random? What does that look like? We're also going to, once we have them mapped to Tucson, we can use the forest data to see if there are any sort of common environmental factors, which we'll touch on briefly. And then we can perform a regression analysis that's going to try to link the population and characteristics of the census block demographics to pedestrian fatalities. Then finally, to try to give it a bit more insight into pedestrian movement, we're going to use an echo analysis that creates buffer zones around those fatalities to incorporate into a regression model to see if that improves our results at all. So in order to get our data into a reasonable, usable form, this is what it looks like. The FARS, we're downloading from the FARS FTP database. Like I said, those are comprehensive. Each year provides like 20 plus CSV files. The one we're most interested in is the person CSV file that has all the pedestrian fatality data in it, but that does not have geolocation data. So I had to use Python to basically link that with the accident CSV data. There is a common field, which is the state case, that's used across all of those CSV files. So I merged those, and then once I had that, I could display that XY data in our GS Pro, and then clip it to our boundaries area that was provided from government data. And that got us 1 year of pedestrian fatalities. So we repeated that process 5 times and got us into the results for the study. And then on the right-hand side, you can just see that I was using a version of the ACS that was provided through the AZ GeoHub and prepared by the Maricopa Association of Governments, and it was very nice and clean to clip to the Tucson boundaries shapefile I used in the FARS data preparation to get us the block group data that we needed for our study area. This brings us to our results. So first up, we have our pedestrian fatality demographics versus the total population of Tucson. And you can see a couple things here. First of all, the victim population tracks significantly more male than the population as a whole of Tucson, and significantly older. And the older portion certainly tracks with a lot of the national studies that were examined in the literature review for the study. Older people are much more vulnerable and likely to be victims of pedestrian fatalities, whereas younger populations are more likely to be involved in vehicle pedestrian accidents, but not necessarily fatal accidents. In terms of ethnicity, the population tracks slightly less Hispanic than the population as a whole, and the non-white population is slightly less likely to be involved in a pedestrian accident. But there are a couple of things we need to point out. The first of which is the asterisk at the bottom that shows that the numbers that we're looking at for race in terms of population of victims is only looking at the first 2 years of our study period. So 2017 and 2018, FARS data was not available for Tucson, Arizona, that incorporated race for the final 3 years of the study, which had the most significant number of fatalities. So that's important to point out. The second thing is that a large portion of the study, a large portion of the populations were unknown, both in terms of ethnicity and race. And this is pretty typical for data on death certificates. And there's a lot of national research that shows that minorities are significantly underrepresented in sort of reports like this, especially death certificate reports. So next up, what we need to do is map the fatalities. So here's a map of our study area. This is Tucson, and here are our mapped pedestrian fatalities, which you can just visually see from here, some clustering that's rather, that starts to indicate that something's going on. Once they're mapped and we know which pedestrian fatalities happened in Tucson proper, I could extract the FARS data that showed the environmental factors. So this shows that 54% of those occurred on major arterial roads, things like Grant Road, Speedway, South 12th Avenue are highlighted there. And then you've got 80% of these, if you looked at the data, had occurred in the hours of darkness, which is also tracks with the national statistics on pedestrian fatalities. Here's our heat map. I'm using kernel density to determine what the clustering looks like. You can obviously see significant clustering in the northwest corner and southwest corner of Tucson. That's sort of Flowing Wells and Sunnyside neighborhoods, and sort of on that I-19, I-10 corridor. And then there's a very small, sort of slightly less significant clustering in the north central portion of Tucson that's centered around Grant and Alvernon. So then once we have once we've determined that the distribution is significant and we have our pedestrian fatalities mapped, we can then perform a regression analysis. And for this regression analysis, we're looking at the block groups, the data from the ACS that specifically looks at race and ethnicity. And those 9 categories are listed at the bottom. And you can see them out there. And so the results are not great. When we're looking at this, it accounts for the strongest linked variable that we're looking at, which would be percent of minority population from the ACS, maybe accounts for 4% of the variance between block groups. So that's a pretty weak link, and in the context of this study, trying to find some sort of predictive pattern that would help mitigate pedestrian fatalities, it certainly doesn't rise to that standard. But this brings up the problem of pedestrian. And what we need to talk about is that pedestrians as a group are, these fatalities are happening at one point in the process. Pedestrians' nature are moving from one point to another. So where these fatalities happen don't necessarily represent where they live or work, and they are points in transit. So the question becomes, how do we model that behavior for our study? And to do that, we're going to use buffers. And if you look here, here's our map of pedestrian fatalities, represented just as simple point dots, and then we can start to introduce buffers. So here is what the half a kilometer buffer looks like, which is roughly equates to 5 minutes of walking time. There's 1 kilometer, which is roughly 10 to 12 minutes of walking time, and then there's 1.5 kilometers. And the 1.5 kilometer number is really important in our study because the data shows that pedestrian commuting and sort of pedestrian movement patterns are concentrated under 1.5 kilometer trips, and that everything beyond that you're sort of tracking with pedestrian movement typically falls into recreational or some sort of other category that's not day-to-day transportation. So that's what we're looking at here. And here are the results of our buffer analysis. So at the top, we're just looking at our most strongly linked variable, which would be percent minority. And that the first one is we're looking at no buffer at all for 0 kilometers, and that shows us our 4% adjusted R-squared value that we were looking at earlier. As you increase it, you can get up to perhaps 10%. But as you can see with the AICC on the right-hand side, that it's measuring the complexity of the model. So the number of points and the overlapping points sort of get you a higher level of complexity, which isn't necessarily bad. But you can see with those buffers that you sort of get a sense of diminishing returns as you get toward the top end of that 1.5 kilometer scale. So 10% or 9% is certainly much better than the 4% in terms of a model of how census blocks might, and the racial composition of census blocks might affect pedestrian fatalities, but still is a very small percentage and doesn't provide a lot of value in terms of prediction and what we can do for prevention. Here are conclusions. I think the study showed a couple different things. First of all, is that there were significant demographic trends that were significant and clear. The population of victims was clearly much older and more male. Non-white individuals were slightly more highly represented than the general population, but that's not on a per capita basis. So that could skew the numbers on any different sort of way. In terms of environmental trends, as I briefly mentioned, certainly time of day, most of these happening at night and on major arterial roads, certainly confirmed what was happening in a lot of the national data that I was reading about. Geographic trends, clearly there's significance in terms of the geographic distribution of these fatalities. We saw the clustering in the northeast or west and southwest corners of Tucson. But why exactly, we're not sure. And as we saw, the regression analysis maybe could account for 4 to 10% of what that variance is between the census between the census blocks. So that's not a really great predictive model. So in terms of what's next, in terms of research, I think there are a couple different things that I would look at. One, I would look at a more sophisticated model of pedestrian movement. There's a lot of research now that uses sort of geolocation data and cell phone tracking to come up with models of how people move about cities. I think incorporating one of those models or some of that data into the research on pedestrian fatalities would be really interesting, and maybe provide more information in terms of point locations for trips and exactly the types of trips and movement that was most at risk. And finally, the last thing I would look at is the built environment shows extremely strong trends in terms of what infrastructure is there. The research showed this, and our data showed this, that the type of roadway and infrastructure is deeply linked to pedestrian fatalities. And the problem with measuring, and a lot of times, that there's this lag between built environment, construction, planning processes, and when the fatalities are occurring. So I think it would be interesting to expand the time period of the study to something like 25 or 40 years, track progression of roadway construction, planning processes, and look at how demographic trends changed over time, and see if there were any sort of like lagging or leading indicators in either those like planning or construction or demographic processes. But that's a pretty complex lift. So that concludes my presentation, and I'm open for questions.